Okay, good evening everybody. Okay, today we will run through one question that we have in our worksheet. The main reason for to look at this worksheet is actually because of the mathematical manipulations. Okay, we will look in depth of how we actually use the formula to solve a standard wave question. Okay, for worksheet 11, question 2. Okay, the questions mentioned about water wave passing through a lock, etc., etc. Now, the details is in the picture. As you can see, there are a few things that we will want to take note. Okay, let's take a look here. Okay, when the questions mention water wave, okay, students should actually subconsciously make a distinction to identify what is water wave. Okay, in your syllabus, we mentioned that there is two types of wave, which is transverse and longitudinal. Okay, now here please take note that for transverse wave and longitudinal wave, by definitions, yes, the particle vibrations is different from that's the main differences, the vibration of the particle. But in question, how do we actually identify the particle, or how do we identify transverse wave and longitudinal wave straight away? Okay, one of the habit that we always encourage students to know is actually to memorize what are the common examples for transverse wave and longitudinal wave, because by knowing them, it will be easy for students to actually differentiate what is the wave that the question is referring to. Okay, and it's not difficult at all, because in your syllabus, longitudinal wave, there is only one example for it, which is sound. Okay, so if you're looking for longitudinal wave, there's only one example, sound. And the reverse will be true also for transverse wave. Other than sound, okay, most of the wave that we actually dealt with are actually transverse wave. So I will say that you can actually separate these two categories to be longitudinal wave to be sound. Transverse wave would be like other than sound. So common example like other than sound, okay, would be water wave. Okay, it can be what we can always have a rope, okay, or slinky spring. These are the common example that you see that will give rise for examples of transverse wave. So rule of thumb, longitudinal wave, there's only sound. Any other wave that the question dealt with or threw at you in your questions are mainly transverse wave. Okay, even like EM wave, electromagnetic spectrum, gamma ray, light ray, all these things, they actually belongs to the section of transverse wave. Okay, so just take a look at it. Now, other than that, in the question you mentioned something about 6 meter. The lock is 6 meter long, and take a look at there is wave inside the lock. And one of the things that you have to be careful is because the particle given is actually distance, okay, which means that the distance between the waves is the factor between the wave is actually measured in distance, which means that I can actually safely say that there is actually one cycle here, which is actually one wavelength, which is 1 lambda. So for 6 meter, if you look at the picture here, you will find that there is actually 1, 2, 3, 4. There's actually 4 waves inside a 6 meter long lock. Or what I can say is that the lock is 6 meter, which is equivalent to 4 wavelength of the wave itself. Okay, based on the picture. And the picture also mentioned, or the question actually also mentioned that 5 complete wave takes 10 seconds to pass through. Okay, 5 complete waves, 10 seconds. Now, when the question mentioned the first part, wavelength of the wave, okay, don't be in a hurry to rush down to use the formula. Okay, the formula that we always have is commonly that we always remember is V equal to F lambda, and the other one will be F equal to 1 over T. Now, same thing as I highlighted before, when we use the formula, we have to make sure that they are in the SI unit. For example, frequency has to be in hertz. The lambda, if it's in meter, most of the time it should be in meter, then the unit for speed will be meter per second. Of course, if the lambda is measured in cm, you'll find that the speed will be cm per second. Likewise, for t, the unit will be in seconds, and the unit for f will automatically be hertz. Usually for the second formula, the units are actually fixed. So now, when the question asks for calculations of the wavelength of the wave, okay, don't be in a hurry to rush now to use the formula. Look at the question first, okay. The question mentioned that 6 meter long, and in the side 6 meter long, there is actually 4 wavelengths. So you can actually safely say that 4 wavelengths make up 6 meter, and you can actually use it to identify the wavelength, the magnitude of the wavelength. So it doesn't mean that it is a chapter question 11 question, it's a wave question, you rush down and straight away uses the formula. It doesn't work this way. Okay, know the formula, but important thing is actually to appreciate the question, okay, and to see what the question is asking you to do. Then after that, we have frequency of the waves. Okay, frequency of the waves, here I'd like to highlight, okay, a common, I would say, confusion by the kids, okay, by students. Frequency usually refer to 1 second. How many waves am I dealing with? Okay, so the key aspect for frequency is in 1 second. How much do I have? The other things that we have that we like to mention is period. Period is the reverse of frequency, meaning it deal with one wave. Okay, how many seconds? Okay, so actually, if you look carefully, it's like both of them actually measure the same thing, but it's just that in terms of frequency, I'm looking at 1 second, how many waves is being generated. And actually from this information, I can actually decipher one wave takes how long. And if I word it this way, this information will become a period of the wave itself. So that's why we can always safely say that frequency and period, they are always interlinked because they belong to the same factor, they belong to the same information, but it's just that we phrase it differently or we approach them differently. So that's why we have a formula to link them together. F is 1 over T. Okay, so now based on the question is that, of course, the formula is there. Same thing, don't rush down first. Don't rush down to use the formula. Frequency means that in 1 second, how many waves are we looking for? Okay, or why I can say that one wave is how many? One wave, what's the timing? Because if I can find the timing for one wave, I can literally find the period of the wave itself. So if I can find the period of the wave, what I do is I will use the formula 1 over T, and I will get the frequency of the wave directly, okay, straight away. Okay, of course there are other ways to look at it. Okay, example, if I know that 5 waves, okay, 5 waves actually takes 10 seconds. Okay, so if I'm looking for frequency, frequency means what? 1 second, how many waves can I produce? So if I have 10 seconds producing 5 waves, 1 second, how many waves can I produce? So if you view it this way, if you understand the definition of frequency, you will know that it's just a simple proportion question. Okay, 10 seconds, 5 waves. 1 second, how many waves will I be looking at? It will be 1 over 10 multiplied by 5, and you still get back the same answer as 0.50 hertz or 0.50 waves. Okay, so this is the waves, and since I know that 1 second takes 0.5 wave, this information will be actually my frequency, which is 0.5 hertz. Okay, so bear in mind, okay, do not rush down to use the formula. It's important to actually know the properties of the wave itself, like what do you mean by wavelength, frequency, period, amplitude, okay, before you rush down to use the formula. Because once you actually understand the concept behind the properties, then the questions will be actually more straightforward, or is actually more approachable. Okay, now the last part that we have is the speed. Speed, of course, the formula that we look at is V equal F lambda. Since you have the frequency, you have the lambda from part 1 and part 2, you just pump your data inside the formula and you get the answer straight away. So this will be quite easily done. Okay, this will be what I call QED, quite easily done. Okay, so if you look at this question, you'll find that for this question, I would say the important thing or the difficult things for students, or it could be the easiest thing, depends on how you see it, but the important thing about question 2 is not part 3, it's actually part 1 and part 2 is the test of the student's understanding of basic concept like wavelength and frequency. How do I decipher wavelength, decipher frequency from the data given in the picture. And the data, take a look, and the data given in the picture is not the usual format whereby I say, oh, the wave has a wavelength of, let's say, 1.5 meter and it has a frequency of 0.5 hertz. It's not given this way, but it's actually repackaged it in, and it's given the same data, repackage it in different ways, represented differently. So that's why it's utmost important for students to actually understand the question and to understand the concept of the properties of waves. Okay, so I hope, okay, this will shed some light towards what you mean by keywords, or what do you mean by understanding the concept on physics. Okay, any questions? Okay, just leave your questions at the comment bar below. Okay, if not, you can just subscribe to my channel to get the latest update for the video that you have, or the video that you do not want to miss. Okay, if not, thank you for paying attention here. See you.